All right, so let's talk about parametric equations. All right, parametric equations are an alternative to using our basic y equals f of x function notation, and it can be more beneficial than the function notation in many cases. All right, so if you think about a curve being traced out over time, maybe sometimes doubling back on itself or crossing itself. That curve cannot be described by a function y equals f of x. Instead, what you got to do is you got to describe our position along the curve at any given time t by two functions, right? X equals f of t and y equals g of t. So x and y are related to each other through their dependence on what we call the parameter t, right? And again, t is usually time. Does it always have to be time? No, but for the most part, it's going to be time. So you can call x equals f of t and y equals g of t a set of parametric equations. And what we do is we call the parameter t the input, and we can think of x and y as being the two separate outputs, right? So your input is t, and then you have two separate outputs, x from one function and y from another function. All right. So the most basic way to graph curves parametrically is just making a table of values for them, right? That's going to be the most basic way to do it. So what you can do is just choose specific values of t, substitute them each into the two equations, and then take your set of ordered pairs and graph them, right? Now sometimes your t is going to be limited, right? Sometimes they'll tell you which t values they want you to use. Sometimes it'll just kind of be understood from the situation or from the function that you're given. Um, so it depends on the situation. So like in this case, we've got parametric equations x of t equals t minus 1 and y of t equals 2t squared plus 3. And they want us to graph it in the interval from -2 to +2, right? Counting by ones. That's just our graphing calculator notation, right? T minimum, T maximum, T scale. So you're going from -2 to 2, counting by ones. So you can see my table here. All I've done is I've just chosen random value, well, not random, I've chosen the values of t between -2 and 2, counting by ones. So t goes from -2 to 2, and now I can fill in my table here just by saying, all right, well, if t is -2, x is -2 minus 1, so it's -3. Then when t is -1, it's -1 minus 1, so it's -2, right? When it's 0, then it's going to be -1. When it's 1, then it's going to be 0. When it's 2, it's going to be 1. So those are my x values. And then my y values are 2t squared minus 2, right? So I'm not looking at the x column to fill in my y's. I'm looking back at the t column to fill in my y's. So when I square t, I get 4 times 2 is 8 minus 2 gives me 6. When I square 1, I get 1 times 2 is 2 minus 2 is 0. 0 minus 2 is -2. And now 1 and 2 are going to be the same as -1 and +2 were, because it's just t squared. So I'm going to get the same values there. So I'm going to get 0 and 6, right? So the question now is, what are my ordered pairs, right? Well, my ordered pairs are, there's one, there's another one, there's another one, so on and so forth, right? The t has nothing to do with the ordered pairs, right? The t is separate. So the ordered pairs I'm going to plot then are going to be -3, 6, which is here, -2, 0, which is here, -1, -2, which is here, 0, 0. I keep losing a point for some reason. And then 1, 6. Now I lost 2 points. I don't know how that happened. So now what I would do is I would take these. They keep disappearing on me. I don't understand why. The best laid plans, right? So there's my points. So now what you would do is you would connect them with as smooth curve as possible, right? And this is not going to be super smooth because I'm doing it on a tablet here, right? So it looks like we have a parabola here, right? Now the difference is a couple things. One, since I was graphing this only in the interval -2 to 2, I do actually put endpoints on this, right? I don't really want to put arrows on the end here. I want to put endpoints here because I was told to only graph it between -2 and 2. Now, is this curve gonna continue up and to the left and up and to the right? Yes, but when t is between -2 and 2, this is the only portion of the curve that I have, right? So that's the one thing, right? You got to notice what your t values were. And the other thing is, what you always want to do is you want to label what's known as the direction of motion. And what the direction of motion is the direction in which the curve is being traced out as t increases, right? So this is the direction of motion. T is increasing as I go down this table. So I started at -3.6, that's my first point, right? That's where t was -2, and then I moved in this direction. So what I do is I put little arrows here to indicate that I'm moving in this direction. And I ended up here where t was +2, right? This is just a thing that I like to do to give more information. You don't have to do it, but I like labeling the different points with their corresponding t values, because then it gives more information, right? Because each point on a parametric curve actually gives you 3 pieces of information. It gives you the x value, the y value, and the t value where it occurred, right? So this point is -3.6, and it occurred at t equal -2. This point is 1.6, and it occurred at t equals +2, right? So on and so forth, right? So t values, endpoints, and direction of motion. Those are the 3 keys here. Now the second part of this problem asked us to graph the parametric equations with your calculator. All right, so this is a little bit different, and this is an important skill to be able to do on the calculator, graphing parametric equations. All right, so what you'll see is normally, right, when I hit y equals, I just get your basic menu that has y1 equals, y2 equals, y3 equals, so on and so forth, right? This is like for our traditional function notation. However, if we hit our mode button, what we see if we scroll down to this 4th line here, we have function, which is our basic normal notation, right? But next to it, we have this PAR, which is parametric. So if we highlight this and hit enter, we're now going to be in parametric mode. So now look what happens. If I now push y equals, what will appear is x1 of t equals y1 of t equals x2 of t equals y2 of t equals, so on and so forth. So this will now allow me to graph parametric equations, right? So what I can do is just enter x1 of t as t minus 1, right? And I use the same button, right, that I used for my input variable with functions, x, this button that says x comma t comma theta comma n, and that's why it says x comma t comma theta comma n, right? Because each of those variables is used in a different mode. So we use the t when we're in parametric mode. So x1 equals t minus 1. y1 is going to be 2t squared minus 2. And that's it, right? We're set. Now the difference is also going to be seen when we push window. When I push window now, I not only have xmin, xmax, ymin, ymax, I also have this tmin and tmax, right? And this is important that you fill this in correctly, right? My t values in this problem went from -2 to +2. Now step, yes, I used 1 in my table, but I knew that I would have to connect with a smooth curve, right? The calculator doesn't know this. So when you choose t-step for parametric equations on the calculator, I generally tell people to keep it what it is as long as it's very small, like 0.13 something, right? Or if it's not small, I just usually tell people to make it 0.1. That's usually pretty safe because then it provides enough points to make it look like a smooth curve. Because that's all that this is going to do now. What this calculator is going to do is it's going to plot a bunch of points that are 0.1 apart from each other, basically, in terms of t, and it's just going to connect them. So you want to make that t step small. And now the x and the y, I can just follow my guide from my grid here on my paper, right? So my x went from -4 to 2, because I'm going to want to recreate this as good as I can. And my y went from -3 to 7. All right. And the other thing that you usually want to do before you graph it is you go over here to this and hit enter until you see this, right? That little line with the circle, and that's going to help you see how it's being traced out. So now if I hit graph, I'll see what happens. And isn't this exactly what I had done on my paper? Yep, sure is, right? So I started there at -3.6, went down to the right, and then back up, and I ended at 1.6, right? And notice how that doesn't go beyond this because I set my t range to only go from -2 to 2. So there it is. That's my parametric mode on the calculator. And then I can look at other things like calc, and you see when I go to now second trace, which is calc, the only option that I have that we could possibly use, right, because 2, 3, and 4 are calculus related, so we're not going to do those yet, but I can use calc value. But when I do calc value, look what happens. It gives me a t value. So if I want to see what point this curve is at when t equals -1, there it is, -2, 0, which is what we said over here, right? So that's how I can do that. And I can also look at the table of values, which is just identical to what I have here, right? -3.6, -2, 0, -1, -2, 0, 0, and 1.6. Now it gives me t values beyond what I graphed, but in this case I'm only interested in the t values between -2 and 2, right? So it works similarly, it just adapts to fit the parametric form. So it's a pretty nifty thing.